from the beginning. That's fine. Yeah. So the purpose of this evening, as Sagar said, is just to give a little bit more insight, starting at a fairly basic level and possibly refreshing the knowledge of a lot of you on the presentation as to the clarification of different types of breathing apparatus, and then starting to go into a little bit more detail around some of the standards and the cleaning and processing of that equipment. So just to begin with, by introducing Breathe Safety Group. As a group, our mission is to be trusted to sustain life in hazardous environments. Everything that we get involved in the three divisions that make up the group is geared towards sustaining life where personnel have to enter hazardous environments. So our background stretches back around about 28 years, over 25 years experience in the breathing air, confined space and respiratory protective equipment markets. And the Luno Systems division of Breathe Safety is specifically dedicated to the manufacture of life support breathing air systems. As you can see from some of the pictures and text on the screen there, we manufacture everything from breathing air helmets, communication systems, through to breathing air cylinder trailers, compressor systems, and other long duration breathing air systems. We are kind of just moving on. We're a category 3 PPE manufacturer. So as many of you would be aware, we're accredited and audited to certain standards for the manufacture of those products. And there's kind of a few more of the key developments that we've worked on. What that's underpinned, just to give you a bit more context of what else is in the group, that's underpinned by a UCAS 17025 accredited laboratory where we test new products to make sure they fall in line with EN and OSHA standards, and create and submit the technical files on behalf of other clients that manufacture equipment as well. So that means we have a very strong research and development team, and it's very nice to be invited on calls like this to hopefully share a little bit of that knowledge, and then from the questions that come in, find out some of the challenges that you face out there day to day. So I wanted to start just by covering some of the key differences in the three main types of breathing apparatus, which are escape, self-contained, and airline. In our kind of day-to-day lives, we'll glibly hear the term BA or SCBA, and I thought it was just be useful for us to begin the call just by getting some of those key differences clear in our heads. So BA stands for breathing apparatus, and that's required anywhere where you're entering a noxious or toxic, hazardous environment, and you can't safely filter out that contaminant. So then you need to go to breathing apparatus, or sometimes known as supplied air, where you're being fed from an air source that's independent to the atmosphere around you. And there's three main types. The first type is escape breathing apparatus, and as the name suggests, it's used for self-rescue from an environment that has become hazardous after entry. And a classic example of that is similar to the clip we saw at the beginning of this meeting, is in confined spaces, where you might enter an area where there's no current presence of gas or oxygen deficiency, but there is a risk that could change, and then you require an escape set to safely evacuate that space. It's worth just making the distinction there that escape breathing apparatus isn't to be used for entry into an oxygen deficient or hazardous environment. It should only be used as a means of self-rescue from a previously safe space. They typically comprise of a small compressed air cylinder, so either 2 or 3 litre in size. You can get a variety of different pressures in those, but typically there'll be 200 or 300 bar, and then a face piece. And usually the option is there for a positive pressure close fitting face mask, and regular users of breathing apparatus that are familiar with a face mask will usually prefer that because of the comfort and familiarity of that. But probably the more common face piece is a loose fitting hood, and the reason for that is that irregular users that may be taking these escape sets into hazardous environments but not using them that often will find it a lot easier to don this type of hood in an emergency situation. And it's also worth noting that loose fitting hood accommodates users with facial hair and glasses a lot better. So if you're wearing PPE or you have facial hair or you wear prescription spectacles, it's a loose fitting hood is a very good option for covering that. Then we move on to working breathing apparatus, and the first type of working breathing apparatus is self-contained breathing apparatus, or you may hear it referred to as compressed air breathing apparatus, and that's used for entry into known hazardous environments. So if you know there's a risk of something like hydrogen sulfide, or there's an oxygen deficient environment, that's what you use to enter. And probably the most familiar example of that is fire services, and they will use self-contained breathing apparatus to enter areas where there's smoke and noxious gases already present, but it's also used a huge amount in other areas where there's an asphyxiant present or oxygen deficiency. So moving on to some of the components in a self-contained set. You'll see on the picture on the left there the different components. And the first is a compressed air cylinder. So they vary in size. Usually the smallest is 6 litres up to 9 litres. There are a few options outside of that, but they're the most common. And 200 to 300 bar is the most common, although 450 bar cylinders are making a bit of an entrance into many markets. Then the back plate that holds the cylinder, and that usually incorporates a regulator that reduces the air from the high pressure cylinder down to medium pressure. Medium pressure is typically 5 to 11 bar, and then that's supplied by some sort of final valve, a demand valve, or some sort of final regulator to a facepiece. The key advantage of self-contained breathing apparatus, and this is an advantage as opposed to airline breathing apparatus, which we'll move on to in a second, but the main advantage is the autonomy to the user. You can move freely around a space or within an environment without being attached to an airline. But the disadvantage is that you only have that supply of air that you're carrying with you, and that it usually is somewhere around 35 to 45 minutes. As you can see there, the calculation given is for a 9 litre 200 bar cylinder, and sometimes that cylinder can make it difficult to manoeuvre in very tight spaces, particularly when you come to tight petrochem and offshore platform applications or marine environments where you're having to navigate very tight manways. Moving on to airline breathing apparatus. This is where the air supply is removed from the user and fed via a compressor or an airline cylinder bank to the user. And they're used where work is relatively localized and for long durations. A typical example of an airline system in use is tank cleaning. So a large tank might take a number of days or even weeks to thoroughly clean from start to finish. And so airline breathing apparatus is very good in that scenario where there's an awful amount of air needed within a relatively small footprint. The airline breathing apparatus system comprises of a compressed air source. The air quality must be tested to, we've put in there EN 12021, but you're probably all familiar with grade D, the US breathing air standard as well. And that'll be supplied either from a cylinder bank or a breathing air compressor, which might be a fixed facility in a factory or something mobile. Then there's an airline harness that the user wears, and that's for them to attach the airline onto. And as you'll see in the picture there, that often incorporates an escape cylinder leg mounted to the person in that picture. And that it means that if for whatever reason that airline supply fails, then they have a short duration supply on them to safely exit that space. And then the final component is the same as all the other systems in terms of a face mask. So the advantage is very clear that it allows a user to work for pretty much unlimited duration, depending on what air supply is feeding them, without the requirement to exit from that space to refill or change a cylinder. But the main disadvantage is you are attached to an airline, and that can get tangled on things and does obviously limit the distance you can work from that entry point or from that air source. So just to summarise some of the key different types of airline breathing apparatus system, there's a few more options with airline breathing apparatus systems than there are with the previous two systems. So look, just looking at this table here, if you were to run from a fixed compressor system in areas where breathing air is required regularly, the advantage of that is it's installed, it's ready to use, they're usually very large, very capable systems. Disadvantage is, however, that it's costly to maintain and it's not easy to move that around. So typical use for those is factories or spray shops, where that lack of mobility isn't a problem, cost to maintain isn't a problem because they are being used on a very, very regular basis. When you move on to a mobile cylinder bank or trailer, the advantage of that is you have known air quality. You're relying on air from a cylinder. You're not drawing in air from around you as you would be with a compressor, and it's mobile. But usually they're very large, they're very heavy because of the number of cylinders required to give you a sensible duration, and obviously they require refilling. But they're very useful for drilling platforms and onshore applications where there's a significant risk of a very quick change in the pollution of the air around the work site. And then finally, a mobile breathing air compressor. The advantage of this is it's mobile again, smaller and lighter than air trailers because you're only towing a compressor around as opposed to a large cylinder bank, and they only require refueling, which is typically easier to accommodate than a charging compressor. But the disadvantage of that is that if the air quality changes very suddenly, that could contaminate users unless you've got some sort of additional monitoring or live air quality tracking system on there. But a typical use for those is tank cleaning, shot blasting and coatings applications, or culvert cleaning, any other long duration entries where you may need that air for an extended period of time. So that kind of leads nicely into the next section that I wanted to talk about, which was EN 12021, or really air quality testing. So kind of apologies for the regular EN 12021 references, if that's not standard you're familiar working to, but the principles are the same across any air quality standards such as grade D, as I mentioned earlier. So compressors that produce breathing air, either direct to the users or that are used for recharging cylinders for self-contained breathing apparatus or airline cylinder trailers, must produce air in accordance with an air quality standard, and it must be tested to confirm that. And that's simply because the quality of air from compressors, it can vary a huge amount, and it's important to ensure that contaminants within that air source are being suitably controlled. So the first thing really is probably to understand what those contaminants are. And again, they are common across most standards. And if we just move on to the next slide, this table here shows what those key contaminants or components are that we test for. First is odor, and the reason for that is an unusual odor or taste in the air is very distracting if you're using an airline system. It often points to an underlying issue of some other contaminant present, but all that aside, is very distracting if you're relying on an air source to keep you safe in the environment. If there's some background odor or taste, it's very, very distracting. Oxygen, absolutely critical, as I'm sure you would all be well aware. Low oxygen is going to asphyxiate the user, and high oxygen presents an enhanced flammability risk. Carbon dioxide, again, is an asphyxiant or an intoxicant, so we need to make sure there's not too much of that present in an air supply system. Same reason for carbon monoxide. They're contaminants that will have adverse effects on the user. Presence of oil is also important to monitor for two reasons. The primary really is ill health, but even if you have a food grade oil in your compressor system, which you can get, which won't necessarily be unsafe to the user, oil will not do your breathing apparatus any favors and will likely lead very quickly to a failure of the breathing air system. And then the final section is water, and you'll see there's different criteria for water in an airline as opposed to water at high pressure, and that's simply because free water can condensate, and it can freeze, or it can cause corrosion or malfunction of the components that make up a breathing air system. So water in itself is not hazardous to a person, but the effects of it present in an airline or self-contained system can be catastrophic. Moving on to frequency of testing, you need to make sure that there's some sort of regime in place to ensure that you're testing regularly enough. As a good rule, static systems should be tested every 3 months. And that changes when you move on to mobile systems. So with a mobile system, you would need to be air quality testing every time that's moved, or when the conditions around it change. So some large change in temperature or plant operating in a nearby area, that can affect the quality of air that a compressor system is producing. So it's just worth bearing that in mind, that you may have an air quality testing regime in place, but it may need reviewing if you're moving a system or something around it is changing. Then just moving on to how we test, there's a few different methods. The most popular is a detection tube test, and I'm sure many on this call would be familiar with colorimetric tube testing for substance testing of contaminants in pipelines, in facilities, pre-entry testing for confined spaces, and that's also used for air quality testing as well. It's pretty quick and easy to perform, and it gives a reasonably accurate indication of any issues with air quality. I say reasonably accurate because the readings on colorimetric tubes, it can be difficult to get an exact reading, but what it will tell you is if that system is borderline, and that will then allow you to move on if you deem necessary, either to rectification works to the system or a more detailed and accurate form of testing. So some clients will specify a laboratory test, quite popular with very high tolerance industries in food production environments, maybe defense applications and things like that. But the problem with that is, although that's far more accurate, it does take a lot longer and costs significantly more because of the logistics of getting that air sample from the air production device, compressor basically, to the lab where that will be tested. There are, however, some options to that now with things like the AirTrack product and other similar products that can be installed into a mobile or fixed system and will give live air quality monitoring capability. It then negates that need for a regimented test cycle, because you know that any air that's being produced is to the correct standard. And many of those systems now will have alarm outputs or relay outputs that can turn a compressor system off if they recognize a contaminant level creeping up. So before contaminated air reaches a user or a cylinder, that system is turned off. Next slide, if you will, Sagar. So just in summary, to those kind of two sections before I hand over to Sagar to carry you through the rest of the presentation, it's important that if we're using compressed air, we understand the requirements for specifying the most appropriate system and solution for the environment that we're going to be working in and the users that we're using it, and then making sure that's backed up with correct air quality monitoring, either where those cylinders are filled or at the job site if a mobile compressor is being used, to ensure that we're keeping those users safe, both from immediate and long-term health conditions. That concludes my input on this presentation. Over to you, Sagar, to carry it on.
Thank you, Adam. Thank you for the lovely presentation and for covering those two topics. And I could see that a lot of points dealt with that. And I will continue from here, guys. So this is a continuation to what Mr. Adam told in the first topic about the different types of breathing apparatus. And one of the types of the breathing apparatus, which is very important in the petrochemical industry today, is the long duration breathing apparatus. So long duration breathing apparatus is a type of system where breathable air required for a sustained period of time, which cannot be accommodated by a self-contained breathing apparatus or a small escape apparatus. In that case, or in that space of time, you need to use long duration breathing apparatus. uh, they are usually fed via an airline, like for example, if SCBA has to be compatible with the long duration breathing apparatus, it has to have an external airline connection so that it can connect to a medium pressure airline from the air source that is going to feed it. And this is where long duration apparatus come in, and that gives them more time and to complete the activities what they're into. So jumping to the next topic of, when you're using a long duration breathing apparatus, there is a very important parameter and aspect there of knowing how do you calculate for the amount of breathing air that is required for the kind of job that you're getting into. Though it is very simple or very basic, but there are some key parameters that we usually ignore while calculating the breathing air volume required for the number of users. So this is as per the UCA standard that our lab is approved, and these calculations we generally use for all our systems, and it's been there in practice since past 10 to 15 years for our company, and I would like to share this with you. So basically, when you start, you know, trying to calculate the capacity or the breathing air required for the number of users. So we start with the simplest thing known as the water capacity, which is the size of the cylinder. For example, if it is a 50-liter cylinders, so the water capacity is 50 liters, that is the volume of that cylinder, and you tend to multiply it with the number of cylinders that you're going to use. So this will give you the overall capacity. Then jumping to the next line is, how do you calculate the total number, the free air volume of the cylinder? It is by multiplying with the charging pressure, which is around 200 or sometimes 300 bar. So depending on the charging pressure that you're using for the cylinder, using to compress the cylinder, there is something called as a compressibility factor, guys, which is something which is a kind of a factor used to identify the deviation which is caused in an idle scenario when you're using it in a real-time scenario. So, for example, the compressibility factor for 200 bar pressure is around 0.96, and when you're compressing the cylinder up to 300 bar, the compressibility factor is 0.92. And when you multiply all these things together, you get the total number of cylinders, total number of liters, sorry, the free air capacity. Now, moving forward, when you want to know the overall duration of air source that you can get from this, there is a certain standard that we use in our industries over here. I know it is different in the Middle Eastern part of the world, but the standard in the industry standard over here is 40 liters per minute. So when you get the free air volume, you divide it with the average consumption per user, and you get the overall duration of air source. Now, in an ideal scenario, the breathing air rate of a normal person is 40 liters per minute. But when he's subjected to work in an emergency situation, or when if the situation goes out of control, at that point, the usage of the same person to the breathing air is more than 40 liters. It can go up to 60 liters per minute. So thereby, we need to keep a contingency for the number of minutes that we have. And the overall number of minutes is, we have to deduct 10% for emergency air. That will give us total working time. Now, this working time is usually in minutes, all right? If you want to know the number of working time in hours, you can divide it by 60, so you get the number of working time in hours. And then the number of hours or minutes that you get, when you divide it with the number of users, you'll come to know the working time per user. So this calculation is detailed over here, but usually we do the inverted calculation for this. Like, for example, if we know the number of users. Thereby, we use these calculations to check how many cylinders are required to design the long duration VA. So, for example, a 6-cylinder breathing air system with the water capacity of 50 liters and charging pressure of 300 bar, with this calculation that is there on the presentation, it will give around the total air for 4 users, which is up to 7.5 hours per user. So it is a total of 30 hours that you get as per this calculation. So this is how we do the breathing air calculation for the long duration breathing apparatus, and it can be used to simultaneously calculate the number of cylinders when you know the POB, which has to work there in that environment. The next important parameter when you're designing a breathing air system is to know the size of the air trailers or size of the air source that you use. This is when it is a self-contained system, or when it is a system which has cylinder bottles in it. But this negates the fact when you are using a compressor in place of a cylinder, because compressor is a continuous air providing source. So this will not come into picture then. So to put it in simple terms, we have a fleet of trailers. We call it as batch series, and we have 3 models in it, which is mini, midi, and maxi. So the mini model, which is a 5-cylinder trailer, this gives you a total breathing time of 37 hours. The midi cylinder, which is an 8-cylinder trailer, as per the calculation in the previous slide, this will give you a total breathing air of 64 hours. And the maxi, which is a 9-cylinder or 12-cylinder trailer, this will give you a total of 100 hours of breathing air. And similarly, depending on the amount of air that you need or at the work site, you have to choose the kind of long duration VA that you're going to use. It can also be a cylinder trolley or the modular air trolley. I have discussed about it. Again, the length of, we also have to consider in this the length of the airlines that we use for the job. Because, for example, if the user is working at the site, which is around 90 to 100 meters away from the air source, there'll also be an amount of air that will be wasted within the hose to be used. 40 liters per minute is a guidance for the amount of air consumed for a positive pressure beam mask, but there are other factors that may affect this, which can include the possible leak, the BMI of the users, and if the users are not using a positive pressure, and if they bypass the demand wall in the positive pressure mask, and if they are into a free flow, it goes more than 100 liters per minute. So we have to consider the worst case scenario in this. If we want to negate all these parameters, and if we want to give maximum air to the user at the site, we would rather consider of using a breathing air compressor, as I told you earlier, and this will lead not to going into depth of the calculations and the kind of parameters you need to choose for a long duration VA. How far away could you keep your mobile air compressors or the trailers where it could work? Well, ideally, what we have checked for our system specification, most people that are using it site, they're used to working up to 90 meters away from the trailer, and this is a proven concept. But we have done some testings in our UCAS approval just to do the worst case scenario or the best scenario, for that matter. And that has proved that the mobile trailer or the compressors can supply up to 8 users simultaneously from the source up to the point where the user wants to go, which would be around 150 meters of airline. And if it is if you see guys here, this is the mobile compressor, and this is a retractable manifold. So the way it is done is the manifold is kept at a distance of 25 meters from the compressor ideally, and from here the hose is passed on to the user, up to the length that he requires. So as per our testings, what we have derived is up to 8 users, we could go up to a length of 150 meters. But if you have 4 users, you could also go up to a length of 250 meters from the air source, which is the maximum length that we have tested up to. Usually people don't require such high length, and as we have told, it is industry standard to be using up to 100 meters. But we have done the testing just to make sure that if at all someone is using it, they should know up to what length they could go up to. Going on to the next topic, guys, it is about how you maintain your RP, or to be put in right words, how do you reprocess your RP or the respiratory protective equipments? Considering in today's world and time when, other than sanitization of RP, disinfecting the RP is very much of quintessential importance in today's world. And we are dealing with this inquiry from our end users over here, and we have done a case study on this, and we want to present that in this PPT. So when we talk about RPE reprocessing, traditionally RPE or respiratory protective equipments or masks and breathing apparatus are used, and there remains ongoing challenges to the maintenance regime or for ensuring equipment is safe and operational. During use, these masks will become soiled with exposure to the surrounding environment. And there will be, for different kind of environment, there will be different types of contaminants. So if you list down the kinds of industry that you work and the kind of soiling you can have on your RPE. So if you see in the tank cleaning or oil industry, the soiling or the kind of contaminant that you can have on your RPE would be hydrocarbon. If you see the pharmaceutical industry, it would be microbial or biological contamination. If you see the fire and rescue industry, it would be mostly carbon deposits. If you see the nuclear industry, it would have more radioactive particulates. And if you use the lead or the metal industry, it would be a metallic particulate. So every industry has a different kind of soiling, and we have figured out on how to use an effective program to get rid of the soiling or get rid of the contamination. Other than the external soiling factor, there is also something called as internal contaminant. Internal contaminant is very important to understand, as there are hazards from within the mask, as the masks are fitted to the face in proximity of the breathing zone. So the exhaled moist air and sweat from the face can contaminate the mask from the within. In addition to this being unhygienic, where a wearer is suffering, if a wearer is suffering from a contagious illness, even if it is simply a common cold, this infection can be passed on to others unless proper disinfection occurs between users. Primarily, this issue is seen where the equipments are pooled or communal for the users, but we fail to give consideration to the people who are involved in the maintenance of the mask as well, as they are also potentially exposed. So these are the two types of contaminants that we are dealing with in today's industry, and we have devised a program to get rid of this contaminant, not just by sanitizing it, but also, as I told, disinfecting the RPE. So it is, as you people will already be knowing of a theory known as the fire triangle. This is a theory what we suggest as a reprocessing program, wherein there are three parameters over here, which is correct equipment, correct chemicals, and correct methods. So for the correct equipment, you need to have a correct chemical, and you also need to devise a correct method to do the successful reprocessing. If any of these parameters are taken out of the consideration, then it would not be a successful RP or a reprocessing program. So our brand, RESPIROCLENZ, is trusted to keep PPE and especially respiratory protective equipment clean, sanitized, and operable. We know how important it is to keep the RPE clean by breaking the physical, chemical, and biological contamination in most of the safe and efficient manner, yet not compromising equipment integrity. So what we have devised in this program is, we have done rigorous testings on all the major manufactured equipments, which gives client the confidence they require, as process and equipment are all backed up with extensive testing and research. We come to the market with the benefit of over 20 years, proven hands-on experience in dealing with the cleaning and disinfecting RPE, which is a great foundation for our clients to put their trust in. Other than having the range that includes cleaners and disinfectants, we also provide equipments which are specifically designed for decontaminating the equipment. The usual method which is used in today's industry is where we rinse the RPs with the kind of chemical suggested by the manufacturer with that chemical, and then we just pass it through water and we keep it for drying. Yes, this is very good to to kill the microbial or the bacterial factors within the RP, but you don't ensure that the RP is 100% dry. And also when you're breathing, if your exhalation valve has some moisture content in it, then that gives you a lot of scope for the bacteria to be there within the mask. So considering this as a major threat in today's COVID-related, or the epidemics that we have here, the pandemics that we are facing in today's market, we have launched this product, which not only where we suggest the correct chemical that we have to use for the RPs, but we also suggest the correct equipments that has to be used for the program after cleaning. So it is always important to understand the difference between cleaning and disinfecting. So when you say cleaning, which is the traditional method that is following, it is the removal of, or the agent needs to be effective against the soiling. So when you are choosing a proper clean chemical, the agent that you choose, it should be a correct agent, and it should be effective against the soiling. Also, the agent needs to have no degrading effect on the integrity of the equipment, which means that when you are using the agent, when you're using a cleaning agent on RP, it should not likely disintegrate the RP product, wherein the RP that is being used in years down the line, it should not degrade itself with the chemical that is being used. Generally, more effective the cleaning agent in this process, more likely it will have an adverse effect on the equipment, which has been seen down the years. But chemicals, and people also tend to use chemical solvents such as acetones or paint thinners to clean it, to clean a kind of soiling on the mask, which is not easily removable. But this is very harmful, guys, because it should not be used, as they will likely degrade equipment very quickly. Like it would be immediate, like within months or years, rather than waiting for some long time. So this is an industry practice which is not guided by proper, or not backed by proper standard, and we want to get rid of this in the whole industry as a practice. The way, or the solution we offer to fight against, or to battle against this, the kind of RP reprocessing, is we try to offer, or we want to offer the chemicals or solutions, how what we would like to offer is the chemicals or solutions, the machines or the methods, to use for the successful RP, or we can also offer consultancy to develop appropriate methods for client-specific requirements, including supporting aids such as guidance poster. And the third thing we wish to offer is design and installation of efficient reprocessing rooms. Why I'm stressing more on the kind that we offer in this program is because we have been approached by the fire brigade here in the UK, and we are offering them a kind of a RP reprocessing room for two of their counties over here, wherein we are doing this project with them, and we are backed by the test that we have done in a UCAS laboratory, which is what we consider much superior what the manufacturer themselves suggest of using their equipment. So our chemicals, or our kind of disinfectants, what we suggest can be used with the regular RP that is in the market, regardless of what kind or what brand of RPs you're using. And with the knowledge, or with the theory to back it up, we are sure that if given an opportunity, we would basically like to consult or develop the kind of reprocessing rooms that the company or your branch needs. So probably we are at end of the presentation, guys, and thank you for being so attentive. We would like to have a small Q&A session, and we would like to have a small feedback form that we'll share you with the Google link, and we would like to know what you feel and what did you learn in this, and what extra points that we added in this presentation to your good knowledge. And handing over to Mr. Ramana from here so that he could maybe share it and get it sorted with you, your team.
Thank you, Sagar ji.
Yes, Ramana.
Okay. So, let me open my video also. Yeah, I'm getting a call. I think some questions are there in the chat box. One question is there in the chat box. Would you be able to see, Sagar ji? What is the international guidelines on hose length? Mr. Abdul Rahman is asking. If you have any info on that, please share it. Otherwise, you can pass it later so that we'll pass it to the member.
Yeah, it's interesting. It's usually the guideline for maximum hose length for airline systems is usually dictated by the manufacturer. So commonly, 3M, Draeger, MSA, pretty much without exception, stipulate a 90 or 100 meter maximum hose length. What we've taken the decision to do on some of our systems is to test them for longer lengths than that. So there's not exactly a guideline per se, but it's dictated by what the manufacturer stipulates the maximum safe working length with their apparatuses.
Yeah, and also as we have said that we are a Cat 3 PP manufacturer, and we have a UCAS approved lab, so where we do the testings as per the EN standard. So mostly for the hoses, the standard that is used is EN 14593. So in that standard, there are a lot of parameters to be covered to do the testing. So when we say our product or the hose is EN 14593 approved, so that is one of the major standards which is used in determining the kind of hose to use. So I hope the question is answered, to Mr. Whoever shared the query.
Yeah, Mr. Abdul Rahman. Yeah, thank you.
Abdul Rahman.
Yeah.
Next question is by Shivraj. Is it a diesel compressor? Yes, it is a diesel compressor. And if need be, there is also an electric compressor. So this diesel compressor is fitted with the air quality monitoring device called as the AirTrack to do the continuous air monitoring as and when it is being used at the site, which is a real-time monitoring solution in today's world, which will be very required or very important. Thank you, Abdul Rahman. Thank you for your kind words, and I would like to see that in the feedback form. Guys, please be open. If you have more and more questions, you can throw it now, or sometimes it is very the problem is we don't want to put the people into the spotlight by asking them, have you learned something, or what question do you have? You can send the questions to us via the chat box, or you could email it to us, or we have given you a feedback form. You could write it to us, and from there we could give you a very rational approach on what are the answers for your, what were solutions for your questions. Capacity of the compressor, so it depends on the requirements, but a standard compressor, the capacity of the compressor that we have is 30 CFM, or he would say 800 liters per minute, to be honest. It's a medium pressure compressor, to be honest, and which is like 10 bar output pressure. So that is why it's a low pressure, high flow compressor. Yeah. Any more questions, guys? Yes, Riyaz Sharif, as I've told you, the mobile air compressor, it is fixed with an air quality monitoring system that is built in accordance to EN 12021. So not only CO, but it monitors CO2, oxygen, oil content, and the dew point pressure. So, and also toxic gases like, hydrogen sulfide if need be. It is a very handy device, and you can configure it as per your requirement, but the standard EN 12021 parameters are covered in the compressor. Yes.
Yeah, if another question is there, you can raise the hand or you can open your mic and speak.
Yeah.
You can put in the chat box so that we can share it to the speakers and we'll get the info. Now is the time for online quiz. I'm going to share a link. Just
yeah. Yes, yeah. I see that people tend to or are more inclined towards the compressor, or most of the questions are related to the compressor. What I could also do is send you the data sheet of the compressor, or we could share the catalog of Luno systems via Raja Group. They could do that to you, and you could see the parameters. Yes, it is meant for hot weather conditions, like it is meant for 55 degrees ambient. Yes, it is. It does not need to be an oil-free compressor because we have a, the kind of monitoring that a device does. It checks oil in it, so oil is used for lubrication. So we don't have an oil-free compressor. The second is, yes, we also have an alarm device. Whenever the parameter goes above the set limit, a compressor gives out an alarm locally, or you could connect to our air track device, wirelessly, and you could get to know that there is an issue in the compressor. So there are two possible alarms in this kind of in this configuration. Yeah. Anyone who wants to come out in open and like on video chat and maybe shoot some questions, we are good for that as well. Or if you want to maybe stay away and write it on a feedback form, we are quite okay with that as well. Not a problem at all. Or else I could tell Mr. Ramana to maybe share the quiz with you people just to see how attentive you all were, or how good we were in delivering this presentation to you people, and to understand how good we could communicate. So is it okay, guys? Mr. Ramana, can you take it ahead from here?
Yeah, thank you, Sagarji. I'm going to post the link. I request everyone to participate to get the participant certificate, and there is no hurry, because earlier we used to do some what you can say, recognizing the quickly answered people. Now we are not going to do that because it requires some time. So there is no hurry in answering the questions, because we have also attached the feedback form to the quiz. So take your time and answer only once. Okay, those who have answered twice, you will not get the participant certificate. I request you to answer once only. If you want to check your answers after submitting, you can check your score, and you can check your answers also, if whether you have answered it correctly or any errors are there. Okay, so no need to go for second time, because previously we saw some people going thrice and even 4 times also. That's why the link will be open for only 3 minutes. Okay, because I'm not calculating the time, that's why I will make it for 10 minutes. Okay, but we are not going to waste the time. In between, we can go for networking, and we can even ask the questions if you have any to the speakers. Speakers are available here. Okay, you can shoot your questions so that they can answer. Okay, link is posted, and you can participate in the quiz now. If any questions are there, you can ask, please. And those who wants to open your mic and talk, you can. It's open for networking. All are busy in participating in the quiz, it seems.
Or it seems like a very good presentation then.
Hello. Yeah, good evening. Hello.
Yeah, good evening, sir. Tell me.
Yeah, good evening. There is one concern regarding this compressor and your panel. What is the distance is allowed as per the system?
It is 25 meters, which is ideal, because the hose that is used between the compressor and the panel, it's a hose with a higher bore, and depending on that, the distance from the panel to the user is decided. So with considering 25 meters between the compressor and the panel, and with 8 users working together on the user end, you can have a distance of a maximum of 125 to 150 meters. 150
meter we can keep it. The panel and the compressor, am I right?
No, the panel is, so there are 3 things, sir. There is a compressor. Okay. From there is an output which goes to a retractable manifold, which is the panel.
Yeah. That's my question is there is the manifold and compressor distance.
Yeah, it is, as I said, if you take 25 meters, we can suggest 25 meters, sir.
25 with the maximum.
Yeah.
Okay. Because most probably we have the tank maintenance and everything. Why they are not allowing the compressor? Because of the atmosphere is confined space and the air polluted. So compressor we can keep it in a way, and we can use this panel. Panel is nearby there, and the entry person and the entrant can know what is the value and all these things. So that's the concern. So this maximum 25. Okay.
So from the panel and the entrant, there is a distance of 150 meters again. So, basically that is what why we tend to give a removable panel is just because of this, so that they're not hooked up to the compressor and you have an additional distance between the compressor and the user again, and it becomes easier for people to hook up to a retractable manifold rather than the compressor. That is the whole idea over here, sir.
And all the SCBA and all the the hoses and everything, all are the same brand, same company, Luno?
Yes, sir. All come under our brand. Yes.
Okay. Okay, fine. Okay, fine. Thank you.
Thank you. Alvin Jose has asked a question that can a compressor be shared with for BA and some other work, for example, grid blasting? Yes, it can be done like that. And, just we need to add a booster pump in that, and, it can be done. We have a product which is specially designed for, grid blasting, that is wet blasting jobs. So along with supplying BA. So yes, we have that. That can be done. I will. What I would also do is, Raman, I could share my email ID, in the chat box, and or do you want to keep your email ID and then you want to send me emails? How you want to get this sorted?
So we can share. We have a list of participants, right? Those who have attended. We can share.
No. Just if someone wants to write an email or shoot an email to us, probably.
Yeah. That usually they will send to us and we are forwarding to you.
Okay, great.
If you have anything, you can share it also. If you have any slide, with those details, you can share it out there.
Yeah. Can share a catalog. Yeah.
Yeah, okay, thank you, Ji. Okay, as a token of appreciation, we are going to felicitate both the speakers. Thank you, Mr. Adam Moodie and Mr. Sagar Shetty, for your wonderful presentations. And I hope people got much information. And if anyone would like to get more info, they will come to us, and we will request you to give more information, like few chart informations, like chart questions we already seen. If we need further information, already we have put the questions in the feedback form. Okay, accordingly, we'll plan for the another meet or something in the future. We thank Roger Trading Company for bringing Luno Systems into and Safety Plus World to present this webinar, especially our Sagar Shetty ji. You are coordinating this one, and thank you once again for this opportunity.
Thank you for letting us do this, and thanks Raja Group also on this wonderful opportunity, as I thanked earlier. And it was a very active participation. People had so many queries, and though it is so basic, but still there are a lot of things that can be learned or can be shared. And with their questions, probably we would learn to explore some areas that we maybe not be exposed to till now. So we're looking forward to more and more queries and active participation. And yeah, probably we could have much more webinars like this in the times to come. Adam, you want to add something?
Yeah, just to add my thanks to that. It's been good, and any other questions that people think of afterwards, please do share them in. It's always interesting to hear kind of what goes on different sites in different areas, because that then kind of feeds back into our sort of research and development cycle of what challenges people might be facing. So any questions, any feedback, queries, examples, much appreciated, and thank you again for the opportunity to speak to you.
This is Rohit Merchandani, the CEO of Raja Group. I want to thank AHSP. Thank you, Adam, Moodie, and Sagar Shetty for a lovely presentation. It was very informative, even for me, although I've been doing safety for the past 25 years. Thank you again. It's Safety Plus World, bringing the best of brands on the table for everybody in Kuwait. Thank you, guys. Thank you for organizing this, ASSP.
Thank you, sir. Thank you very much. Okay, Sagarji, shall we close the meeting?
Yeah, I'm sure we could get the feedback from there.
Thank you.
All right,
the link is open for a few more minutes, but I think it's already quarter past our allotted time, so we can end the meeting. Okay.
Sure.
Thank you, guys.
Thank you, guys.
Thank you very much for your participation.